Hello there. Welcome to brilliantmaths.com, where every student has an opportunity to excel in math. Brilliantmaths.com has resources for both primary and secondary students to help with self-study. We have lots of resources and lots of videos there too. The Brilliant Maths modules from 1 to 10 cover the secondary school mathematics syllabus. So if you use the modules, you will cover your syllabus in no time. Today's lesson is taken from Brilliant Maths Module 5. If you don't have a copy, please grab one and let's work together. Today we'll be looking at sequences. A sequence is an ordered set of numbers or patterns that follow a rule. The important thing about sequences is that it follows a particular rule. There's a rule for each sequence. Some examples of number sequences are sequence of whole numbers. We all know whole numbers, 1, 2, 3, 4, but we really may not have known that it's a sequence. So it's a sequence. Sequence of whole numbers, sequence of ordinal numbers, talking about positions, first, second, third, and so on. Counting numbers, odd numbers, 1, 3, 5, sequence of even numbers, 2, 4, 6, 8, and so on. Sequence of square numbers, 1 times 1, 1, 2 times 2, 4, 3 times 3, 9. So 1, 4, 9, 25, and so on. Sequence of prime numbers, numbers that have only two factors, 1 and itself. For example, 3, 2, 5. Those are examples of prime numbers. Sequence of triangular numbers, sequence of composite numbers, Fibonacci numbers, palindromic numbers. These are all sequences that we already know. There are also linear sequences, quadratic sequences, and exponential sequences. Let's discover a simple test to find out what kind of sequence a sequence is and then how to work with it. So let's look at the second sequence. We're finding the first difference. 12 take away 8. 12 take away 8 is 4. 20 take away 12. 20 take away 12 is 8. 32 take away 20. 32 take away 20 is 12. 48 take away 32. 48 take away 32 is 16. So as we can see, the first difference is not constant. It's increasing by 4 each time. This is 4, 8, 12, 16. So we'll find the second difference. 8 take away 4 is 4. 12 take away 8 is 4. 16 take away 12 is 4. So the second difference is a constant. As we can see, in this first sequence, the first difference is a constant. So we said that that is a linear sequence. In the second one is the second difference that is a constant. So this is a quadratic sequence. So the first test you do when you get a sequence is to find out if it's linear or quadratic. That will help you know how to solve it. So for example, in this sequence, if we want to find the next two terms of the sequence, we simply add 4. So if I ask you to find the first 7 terms, we have 1, 2, 3, 4, 5, 6. The 7th term of the sequence is 25 plus 4, and that is equal to 29. I could call that the next term of this sequence. The next term of this sequence is equal to 25 plus 4, which is 29. Let's see if we can find this next term of the quadratic sequence. 4, 8, 12, 16. The first differences are increasing by 4. So how do we find the next number? We simply add 4 to 16, and that is 20. And then add 20 to 48, and that will give us 68. I'd like to write it in red just to show that we calculated that. How did we get that? Remember that the first differences are increasing by 4. So 8 plus 4 would give you 12. 12 plus 8 will give you 20. 20 plus 12 will give you 32. 32 plus 16 will give you 48. So to get the next one, we're adding 20 to 48. So 20 plus 48 will give us 68. This is a quadratic sequence. The formula for finding the nth term of a linear sequence is giving us Tn. Tn is equal to An plus b, where n is a term, first term or second term or third or fourth in the sequence. The formula for finding the nth term in a quadratic sequence is Tn is equal to An squared plus Bn plus C, where A is half of the second difference, and then Tn is a term. So you input that into two equations, and you solve simultaneously to find the values of B and C. Whilst in the first one, A actually means the common difference, and B is the difference between the common difference and the first term. Let's work out some examples. Let's look at this example. Below is a sequence of numbers, 5, 9, 13, 17, 21, 25, and so on. A, write the next two terms of the sequence. B, give an expression for the nth term of the sequence. And C, calculate the 50th term of the sequence. What do? The first thing is, let's find the difference between the consecutive terms to find out what kind of sequence it is. So solution, we have 5, 9, 13, 17, 21, 25, and so on. So the difference between the first two terms, 9 minus 5, is 4. That's the first difference. 13 minus 9 is 4, 4, 4, 4. We already saw that this is a linear sequence because it's increasing by 4. The first common difference is a constant. So having found that, the formula to find the nth term, we'll get there soon. But the first question says, write the next two terms of the sequence. That means that the next term is simply to add 4 to 25. So A, 25 plus 4, which is equal to 29, and 29 plus 4, which is equal to 33. So 33 and 29, or rather 29 and 33, are the next two terms of the sequence. Then B, give an expression for the nth term of the sequence. B, the formula for nth term when you have a linear sequence is Tn is equal to an plus b, where a is the common difference, n is a term, and b is the difference between the first term and the common difference. But sometimes, some people find it difficult to remember that difference. So you can use this formula. Tn, for example, our second term. So we say T2 is equal to, T2 is 9, and that will be equal to A, common difference, which we know as 4, times 2, because n is 2 in T2, plus b. We want to find the value of b. So 9, b will be equal to 9 minus 8. 9 minus 8, which is equal to 1. We have used the second term that we know to find the value of b. But remember that I said that b is a difference between the first term and the common difference. So 5 minus 4 is 1. So the nth term for this sequence will be equal to our a, which is our common difference, is 4. Nth term will be 4n plus 1. Let's check that and see. 4n plus 1. Our third term is 13. So that is 3. 4 times 3 is 12. Plus 1, and that is equal to 13. So the formula for the nth term is correct. Let's calculate the 50th term of the sequence. That just means that n is 50. So C, 50th term equal to 4n plus 1. 4 times 50 plus 1. And 4 times 50 is 200. 200 plus 1 is equal to 201. So the 50th term of this sequence is 201. Assuming we started adding 4 each time until we get to 50 terms, the 50th term will be 201. Let's look at this example. 8, 12, 20, 32, 48, and so on is a sequence. A, find the next two terms of the sequence. B, give an expression for the nth term of the sequence. And C, find the 10th term of the sequence. So let's work this out. Let's take the solution. The sequence is 8, 12, 20, 32, 48, and so on. The first difference is the difference between consecutive terms. So 12 minus 8 is 4. 20 minus 12 is 8. 32 minus 20 is 12. 48 minus 32 is 16. So as we can see, the first difference is not constant. It keeps increasing. By what? So we'll find the second difference. 8 minus 4 is 4. 12 minus 8 is 4. And 16 minus 12 is 4. So the second difference is a constant. That shows that it's a quadratic sequence. The first question is to find the next two terms of the sequence. So we have 48. But as we can see, the first difference always increased by 4. So we simply add 4 to 16, and that gives us 20. So you add 20 to 48 to get the next term. So 48 plus 20 is equal to 68. So to get the next term after 68, you add 24, because the difference will now be 24. So we add 24 to 68 to get 92. So we have answered the first question, which says find the next two terms. The next two terms are 68 and 92. So B, give an expression for the nth term of the sequence. The expression for the nth term of the sequence can be found using Tn is equal to an squared plus bn plus c, where a is half of the second difference. The second difference is 4, so half of 4 is 2, so a is equal to 2. Next, let's use the second term and the first term to find two simultaneous equations to solve for b and c. So T2, which is 12, the second term, will be equal to 2 times 2 squared, because n is 2. So we're substituting the value of n as 2 and the value of a as 2. So 2 into 2 squared plus 2b, because n is 2, plus c. Then in the first term, which is 8, 8 is equal to a, which is 2, n is 1, 2 times 1 squared is 2, plus bn, n is 1, so that's the same as plus b plus c. So we have these two equations. Collect like terms. 12 take away 8 is equal to 2b plus c. That means that 2b plus c is equal to 4, because 12 take away 8 is 4. So that becomes our equation 1. In the next one, 8 minus 2 is equal to b plus c. So that means that b plus c is equal to 6. When we solve this simultaneously, we can use elimination. Let's do that mentally. 2b minus b will give us b. C minus c will eliminate c. And then 4 minus 6 will be minus 2. So b is equal to minus 2. Once you get the value of b, you substitute that value into either of them to get the value of c. So we'll put it in the first equation. B is minus 2. Minus 2 plus c is equal to 6. So c is equal to 6 plus 2, which is 8. So the value of b is minus 2, and the value of c is 8, and the value of a is 2. So we put that into the expression an squared plus bn plus c to find the expression for the nth term. The nth term becomes 2n squared minus b, which is minus 2, so minus 2n plus 8. Let's check to see if this expression for the nth term suits our sequence. So we use the first term, which is 8. So n is 1. We input 1 into this expression. 1 squared is 1. 1 times 2 is 2. Minus 2 times 1 is 2. So 2 minus 2 is 0. And we are left with 8. So the first term is 8. T1 is equal to 8. And our first term in the sequence is actually 8. So the expression we have for the nth term is correct. The last question says, find the 10th term of the sequence. That means n will be equal to 10. Nth term, the expression is 2n squared minus 2n plus 8. So let's work this out now. N is now equal to 10. So 2 into 10 squared minus 2 times 10 plus 8. 10 squared is 100. 100 times 2 is 200 minus 2 times 10 is 20 plus 8. 200 minus 20 is 180. So 180 plus 8 is equal to 188. So the 10th term of this sequence is actually 188. Some of you could take your time to try it out. Just add the differences and get to the 10th term, and you'll see that it's actually 188. Let's look at this example. We're looking at arithmetic progression. arithmetic progression is a kind of linear sequence. In general, the nth term of an arithmetic progression with first term a and common difference d is un is equal to a plus n minus 1 times the difference. N minus 1 is just the term before the nth term. You multiply the term before the nth term by the common difference and add the first term to it. That's the general formula for an arithmetic progression. Let's look at this example. Find the nth term of the sequence minus 1, minus 3, minus 5, minus 7. It's a linear sequence, so you can actually use the method we had learned earlier on to do this. If you haven't seen that video, go look for it. So here, we're finding the nth term of the sequence, and then we're supposed to find the 98th term of this sequence. So solution, we write out the sequence again. Minus 1, minus 3, minus 5, minus 7. What do we see? Find the difference. The first difference. The difference between minus 1 and minus 3. The first difference is minus 2. So the sequence is decreasing by 2. From minus 1 to minus 3, from minus 3 to minus 5, from minus 5 to minus 7, and so on. So the first difference is a constant. So that tells us that it is actually a linear sequence. Remember, our A is the first term, and the D is a common difference. We just checked with minus 3 minus 1, the difference between the first two terms, and also the difference between the fourth and the third term, minus 7 minus 5. And each of the differences give us minus 2. So D is equal to minus 2. The nth term is given by un is a plus n minus 1d. So we now know the value of a and we know the value of d, so we substitute into that expression. So un, or the nth term, is minus 1 plus n minus 1 in the bracket times minus 2, which is the common difference. So we have minus 1. Minus 2 times n will give us minus 2n. Minus 1 times minus 2 will give us plus 2. It becomes minus 1 plus 2 is 1 minus 2n. So the nth term, the expression for the nth term is 1 minus 2n. We've been asked to find the 98th term of this sequence. So we simply put n as equal to 98. Because we've worked it out already. We have the formula for the nth term. When you have the formula for the nth term, for any value of n, you slot in that value, and then you can find the term. So 98th term, that means n is 98, is equal to 1 minus 2 times 98. 98 times 2 is 196. And 1 minus 196 is equal to minus 195. So assuming you continued this sequence and just kept subtracting 2, decreasing by 2, until you get to the 98th term, the number you would have there will be minus 195. We want to look at geometric progressions or exponential sequences. Sometimes you say that figures are increasing exponentially. In mathematics, each term of an exponential sequence is a constant multiple of the previous term. These sequences are also called geometric progressions or geometric sequences. For example, in the sequence 2, 6, 18, 54, 162, and so on, 2 times 3 will give us 6. 6 times 3 will give 18. 18 times 3 will give 54. 54 times 3 will give 162. So that means that 3 is the common ratio. The next term is 3 times the previous term. And in this sequence, 2 is the first term. But the nth term for an exponential sequence is given by un is equal to a, which is the first term, times r to power n minus 1, where a is the first term and r is the common difference. So for example, if we're looking for the fourth term of this sequence, it means we are going to multiply 2, which is a, by 3 to power 3. Because we are looking for the fourth term. N is 4 now. So it will be a times 3 to power 4 minus 1, 3 to power 3. And 3 to power 3 is 27. And 27 times 2 will give us 54. So a is the first term and r is the common ratio. You obtain the common ratio by dividing a term by the previous term. That's how we got 3. We divide 6 by 2. We get 3. If you divide 54 by 18, you get 3. The common ratio is usually the same, is a constant. So for this, what you need to know is that the formula for finding the nth term of an exponential sequence, or the expression rather, is first term times common ratio raised to power the term before the term you're finding. Let's see an example. Let's look at this example. Find the common ratio, the nth and 10th terms of the sequence, minus 3, 9, minus 27, 81, and so on. This looks very interesting. Notice that the first term is negative, the second term is positive, the third is negative, the fourth is positive, and so on. Solution. Minus 3, 9, minus 27, 81, ... Let's find the common ratio. We said that to find the common ratio, you divide a term by the previous term. So we're dividing 9 by minus 3, and then we get minus 3. Just to check if we are correct, choose another 2 consecutive terms. So I'll take minus 27 and 9. So I divide minus 27 by 9, and the answer is still minus 3. So that means that the common ratio is minus 3. And my first term is also minus 3, or negative 3. Remember that the nth term of a geometric progression is given by un is equal to a, the first term, times r, the common ratio, raised to power n minus 1. So we have a is minus 3, r is also minus 3, raised to power n minus 1. But looking at this, we can simplify this using indices. If you don't have our video on indices, go look for it. So we have minus 3 times minus 3 raised to power n times minus 3 raised to power minus 1. Applying the laws of indices, this can be simplified to become this. So minus 3 raised to power minus 1 becomes the denominator. So it cancels out minus 3 on top, so that our nth term becomes minus 3 to power n. Finally, we have to find the 10th term of the sequence. So you simply put a value of n, which is 10. So the 10th term is minus 3 raised to power 10. And the answer is 59,049. It's positive because n is even. And if you look at the sequence, the even terms are positive. For more of this, subscribe to brilliantmaths.com. You can find this lesson in Brilliant Maths Module 5. Grab a copy and just keep solving. And always remember, maths is fun and you